In this video, we're going to be looking at translating the graph of an absolute value function either vertically or horizontally by altering its equation, and we want to graph one of these translations. Now, if you'll remember, this entire module is called transformations, and to transform something means to change it, to make it different somehow, some way. We're going to be looking today at transforming the absolute value function, y equals the absolute value of x, using what's called a translation. So a translation is a type of transformation. And it's a particular type of transformation in which the graph of a function slides. It moves around horizontally, vertically, or some combination of the two. But very importantly, it never changes shape and it never changes size. So if I look at this absolute value function right here, if I'm going to translate this, that means it's going to slide vertically, either up or down, horizontally, left and right, or some combination of that. But notice that the size of that shape never changes, and the shape of it never changes. It always looks like a V. It's never going to transform that way. So again, a translation is just a type of transformation where you just pick something up and slide it around without changing its size or its shape. And so we're going to look at the effect this has on the equation of an absolute value function. And in order to do that, we're going to look at what I'm going to call the vertex form of an absolute value function. And you can see what's been added here. We're used to our absolute value function looking like this, y equals the absolute value of x, but now we've added in some value we call h that we're subtracting from x inside the absolute value bars, and some value called k that we're adding on the outside of the absolute value bars. And here's the meaning of these. That h is the x-coordinate of the vertex. So wherever my vertex is, and I can now move it around, because remember, we're translating this. We're moving it wherever we'd like to move it. So the x-coordinate is going to be h, and the y-coordinate is going to be k. So let's take a look at that using the Desmos graphing calculator. And what I've done is I have set up an absolute value function to be graphed on here. And this function that you see right now in red is y equals the absolute value of x, just like we looked at in our last one. But notice I have h and k built into this equation, and these sliders will allow me to change h and to change k. This should look fairly familiar from that exploration assignment that you did a little bit ago. And what I can see is that if I change h, then what happens is that my vertex moves either to the left or to the right. And so I can see that here my x-coordinate for the vertex is going to be 2. Well, that's what h is. So in my equation that would look like x minus 2, and that gives me a vertex at plus 2 for the x. Notice it's backwards because of the minus sign. Same thing for k. I can put my vertex wherever I'd like. So here my vertex is at 2, negative 3, and you can see h is 2 and k is negative 3. And that's pretty much it. By changing those numbers, h and k, we can change the location of the vertex, which is fairly nifty. So let's take a look at some examples of this. And what I'll do is I'll leave Desmos over here, so that once we have graphed this, I can use Desmos to see if I'm correct. So let's look at example 1. Graph the equation y equals x minus 3 plus 2. So the first thing I want to do on this is to find my vertex. So remember, the vertex is that point of the V, and it's going to be identified by an ordered pair by telling where it's at. So that vertex is going to be at h, k. So I need to look at what's paired up with the x inside the absolute value functions, and that's negative 3. When I put that in for my vertex though, because in the equation it's minus h, I have to flip around the sign so that it becomes positive 3. So again, notice I took whatever number was in that absolute value bar and I changed the sign for x and x only. For y, the sign stays exactly the same. Here the sign was 2, and so that coordinate in my vertex is 2. And again, that comes from the fact that my vertex form of this is x minus h plus k, because that h is being subtracted. When I take that as my x-coordinate of the vertex, I have to flip that. So my vertex is at 3, 1, 2, 3, 2, 1, 2. So there's the vertex of my absolute value function. And now what I can do is I can say, since I know that a translation does not change shape and does not change size, I know that the slope coming off to the right of this is going to be 1. So I go up 1 over 1, up 1 over 1, and I can do that as often as I need because I'm so bad at drawing lines. I will draw a bunch of them. And then I know that coming from the other side of that vertex, my slope is negative 1. So I would need to go down 1 over 1, down 1 over 1, so on and so forth. And so it forms a V with the point of that V, the vertex, right where I found it earlier. And then I can draw those lines. And there you go. Now, granted, I'm doing this on a computer and I'm trying to freehand that. I don't know if you guys know how I do all this stuff, but I have a pencil that I'm drawing this stuff with. And it's a situation where I don't really have access to a ruler to make that straight. Yeah, if I wanted to, I could use the line function in the notebook software, but we're not going to go there just yet. When you are drawing these on a piece of paper, and you're drawing them by hand and not using a computer, where normally I would use Desmos to get a picture of this, but if you're drawing this by hand, I have rulers for every single person in the classroom. Take a ruler and make those lines straight and nice and neat. There's no reason for them to be sloppy like mine is. You can take a ruler, put it down, and very easily get a nice, pretty straight line. That being said, we've got this. Let's see if we're right. So if we come over here into Desmos and we say h had to be 3, so now I would get x minus 3. That looks exactly like our equation there. And k was 2, because we have plus 2 on the outside. That's what my graph should look like, and you can see that's what it looks like here. So I must have done that correctly. Alright, let's look at another. Graph the equation y equals x plus 4 minus 1. Again, first thing I have to do is get my vertex. For my x-coordinate, I take the opposite of what's in the absolute value bars with the x. So instead of positive 4, it would be negative 4. For my y-coordinate, I take exactly what is on the outside, no change to it whatsoever. So my vertex is at negative 4, 1. So I would count off negative 4 in the x direction, 1, 2, 3, 4, and negative 1 in the y direction. Now since my shape did not change at all, I know the slope coming off of this side is still negative 1, or positive 1 rather, and the slope coming off this side is still negative 1. And now I can take all those points, and look at this, I convinced myself to use a nice straight line here. I can take all those points and I can now graph my absolute value function from that. So again, take your vertex, and then we know the slope is 1 coming off this side and negative 1 coming off this side. We can use Desmos to see if we're right. We said our vertex would be at negative 4, negative 1. So now let's check this equation that we would get. Notice now this would be x minus negative 4. Well, subtracting a negative is the same thing as adding a positive. So this equation would be x plus 4, which is exactly what we see here. And then minus 1 for k. So that's what Desmos says our graph should look like. Looks like we did a pretty good job. Next up, one more situation. Look at this one. Graph the equation y equals the absolute value of x plus 2. So when I go to do this one, I need to find my vertex, but something strange happens before I even get started. What number is inside the absolute value bars with the x? There's nothing there. So I have to ask myself, what number is it that I could add to x that wouldn't even show up, that wouldn't change anything? It's got to be 0. So when there's nothing inside with the x, my coordinate would be 0. And then for my y coordinate, it's got to be positive 2. And so I can plot that vertex at 0, positive 2. I know my slope is going to be 1 coming off of this side, and negative 1 coming off of that side. And so now all I've got to do is connect all those together and draw nice, pretty, neat lines. There we go. Remember, you're going to use a straight edge to do that. And now I have my graph. We can check Desmos. If I put in a 0 for h and 2 for k, that's what it should look like. Let's check our equation. X minus 0 would just be x. Okay, that's what we've got. And then a plus 2 on the outside. Well done. Now let's look at the other direction, because we can do this in the other direction too. Write an equation for the function shown in the graph. Well, okay, let's check this out. If I'm going to write the equation in vertex form, I probably should know where the vertex is. So we look at the vertex and we can see it is at negative 2, negative 4. So now I'm going to write my equation in the form of y equals the absolute value of x minus h plus k. Well, h is just the x coordinate, so minus negative 2, and k is just the y coordinate, minus 4. Look at this minus a negative though. Y equals the absolute value of x plus 2 minus 4. And so now what I can see is that my x coordinate is indeed the opposite of what is in there, and the y coordinate is the same as what's in there. And that, friends and neighbors, is my equation. Again, we can check Desmos to make sure that we are indeed on the right path here. So if we set h to negative 2, and let's see, k to negative 4, excuse me, lost myself there for a moment. We can check that. What we can also do is down here, we can just actually write in what the equation is and check it that way, which might actually make more sense in this case. And make that graph show up. I'll just make this our go-to. And you can see now, that one in purple, I believe that is, shows us what this graph should look like. Hey, that's what we've got there. So it looks like we've done this correctly. So let's write another. Write an equation for the function shown. So I need my vertex. My vertex is at 4, 1. So when I write my equation, it's got to be in the form x minus h plus k. Well, my x coordinate is 4. So inside the absolute value bars, I have to have the opposite of that. And then my k value is the y coordinate, which is just 1. Now, if it makes you nervous and you're not liking that I skipped a step here, we can also do it this way to show you more where that came from. I can take y equals k minus, and then my x coordinate was 4, so it's like I'm substituting that in, plus, and then my y coordinate was 1, and you can see it ends up being the exact same thing there. So again, all I'm doing is plugging in those values. Desmos to the rescue. Let's see if we did this correctly. So I want my equation to look like x minus 4 plus 1, and let's see if that's what our graph looks like. Hey, look at that. We've apparently done this right. One last situation to be aware of. What happens with this? Write an equation for the function shown in the graph 2 periods. You know you really want to stop there. So we go up to this thing and we say y equals x minus h plus k. Notice I'm writing the formula down each time. Helps me remember it. I need my vertex. My vertex is at 0, -2. So when I go to write this, the x-coordinate is 0. X minus 0 is just x. So there's nothing inside there. And then my y-coordinate is -2. And so there we go. There's my equation. Very nice, very neat, simple. Good to go. I can check and see if that's right by typing this in. And by the way, you're always welcome to check your work using Desmos. Do the work ahead of time. Don't use it to get the answers, because then you're cheating yourself knowledge. But you can always use it to check your answers. And voila, there we go. So to recap all of this, while I reset this graph for the purposes of our recap. To recap all of this, you have y equals the absolute value of x minus h plus k. That's called the vertex form of the absolute value function. The x-coordinate of the vertex is h. And so you'll see that right there. And if you make h more positive, that is if it's x plus something, then what you're going to see is that when x is positive, or when h is plus something right here, x plus h, then it is going to move it to the left. When we're subtracting an h value, it's going to move it to the right. For k, when k is positive, we're going to move it up. When k is negative, we're going to slide it down. But when it comes down to it, it just gives us where the vertex is.